Welcome to the F1 in Schools project tutorial. My name is Phil Dolan. In this lesson we're going to be creating a new assembly file, then placing the straws in the assembly. We're actually going to be resizing them as well. Then we're placing two axles, the four wheels and the hubs, and finishing by placing the tether guide and the cartridge. I have no files open, so I'm going to create a new assembly. It's a metric template and a standard metric assembly.iam. With that open, I'm going to go up and look at the browser. We can see the assembly, number of options for placing. I'm going to just use place as against content center, which is things like nuts and bolts. I'm going to place a model of the body in the assembly. I'm using the grounded at origin. That removes all degrees of freedom. This is one of my earlier designs. I actually don't have the fillets added to this one. At the end of the tutorial or the lesson here, I'll show you what it looks like when it's completely done. I just changed the view. That original view that came in really wasn't suitable, so I changed the home view setting. And I'm going to save the file. Again, you may have some naming conventions that you have to follow. I'm just using my F1 in Schools car assembly. I'm now going to place some other parts in the assembly. The first one will be the straw for the rear of the car. There are actually three files that are available to you. I've created a specific file for both the front and the rear. They're all the same length. We're going to have to modify the length. So starting with the straw that's at the rear, I'm going to measure between those two faces. And that gives me a distance of 27 millimeters. Knowing that, I can now modify that straw. Just edit, go to the extrusion and edit that feature, change the value to 27 millimeters. In terms of constraining that part into the body of the car, we have a number of options: joint, constrain, and assemble. In this case, we're going to use constrain. The type will be insert. I'm going to select the edge of the straw and the edge of the hole in the body. That's obviously incorrect, so I'm going to flip that around and click OK. Let's have a look at the degrees of freedom. When I turn on degrees of freedom, you can see the straw can still rotate inside the body. We want to remove that. The easiest way to do that at this point is simply to ground that part. So with that part grounded, that degree of freedom no longer exists. We can turn off that degrees of freedom symbol. Back to the Assemble tab. Let's place the straw for the front. It's going to be a very similar workflow. We need to find out the length that's required and then constrain it. So measure the distance. Now a little bit different here. We've got that sloping surface we have to be aware of. So that's 24.173. You can actually copy and paste this. That we'll remember it. Edit the straw, edit the extrusion, and put in that new value, 24.173. For this straw, we're actually going to use the joint. You'll see why in a moment. There are a number of options, all the way from automatic through to ball. I'm just going to let the system decide initially. The center of the straw and the center of the hole in the body, the axle. You can see it still has 1 degree of freedom. I can fix that by selecting rigid. Now that's correct. So we have both straws now placed in the assembly. Let's go up and place some more parts. First of all, I'm going to save that. Yes to all is fine. They're all selected. And you can see the two constraints, the insert constraint and the rigid joint. Should be noticed that you can actually combine all these together by changing to modeling view. So if you have a very large assembly, sometimes that's useful to see what constraints or joints actually exist in your assembly. Let's place a couple of axles in the assembly. Click OK. I'm going back to joint again for this one. two center points. The animation shows us what we've got. There's 1 degree of freedom. I'm going to change that to rigid again. Now the back axle is a slightly different workflow. We can select the midpoint on the axle, but it's a little awkward to get that one. So there's a very easy solution. Just right click and say between two faces. It's almost like measuring, which we did earlier on. Select that face. Select the origin. Rigid's already set, so we're good to go. Now just to check that the axles are correctly located, just a quick visual check, that looks good. They're not way off or anything, so I think our solution is good. Next thing we want to place are the washers that are going to go on the outside of the axles. 4 of those. On the first one, we're going to put a constraint. That will be an insert again, and they're going to go right up against the body. So at the back there, that's fine. Let's do the other one. Slightly different at the front. Because we've got a flat face at the rear there, it works quite well. Notice I'm not going out of the constraint, I'm just applying that. So very similar workflow, but this time I'm going to give it a little bit of a clearance because of that curved surface. There might be some interference. So 0.5 millimeter clearance and we're good. And the fourth one. Again, that's going to be a 0.5 millimeter clearance. So the 4 washers are now inserted into the assembly. And I want to place the wheels and the hubs. Here we see the hub. First of all, I'm going to place the wheel. Obviously we need 4 of those. A couple of things, because of this black color, it's kind of difficult to see the edges, so I'm going to go in and turn on shaded with edges. And the second little hint I want to give you is that it's actually facing the wrong way, but we have this free rotate tool. You can actually just spin that around, and that's the circle that I'm looking for. That's the cylinder. So I can use either joint or constraint. In this case, I'm going to go to constrain, insert, and place it next to the washer. There should be a small clearance there. I've settled on 1.5 millimeters. Click on OK. I've completed the other 3 wheels. Have all been inserted into the assembly. I now want to go and do the same for the hub. So there's the hub. And again, 4 of them. Let's look at how we're going to do that one. In this case, we're going to use a joint. Use the free rotate to see the actual face that we're going to be looking at. It's that one there to the very back of the wheel. So use joint, and move that out of the way. Select the face, and be careful when you're selecting the very back face there. There it is. And that's a good solution. You'll notice it's rotating. I want that to be rigid. Say OK. Now when I rotate the wheel, the hub goes with it. And that's exactly the behavior that I'm looking for. The other 3 hubs are now attached to the wheels, and they're behaving correctly as well. To add the tether line guides, I need a little bit of help. So I've opened up the body. I'm going to create a sketch on the flat surface, not the bottom, but the one that's inside there on the guide, and place a couple of points. What I'm going to do is just put a couple of holes in here. Easier with the hidden edges. The reason why it's easier is the rules, the guidelines say the axle or the guideline at the back has to be behind the axle, and the one at the front has to be in front of the axle. With the hidden lines on, I can see that. I'm using a constraint that centers them in that slot, and then a couple of dimensions. So So the first dimension is going to be 20. And at the front end of the car, this dimension is going to be 40. The holes I'm going to put in are fairly small, so H on the keyboard is the shortcut. 0.75 diameter, just a little guide or pilot hole. I don't want through all, that wouldn't work. I want distance, and that's going to be 5 millimeters. Click OK, and those two holes are created. I can now save that file, close it down, and go back to the assembly. So of course in the assembly that has been updated, and I'm all ready to put in the two tether guides. Open that first one up. I'll just show you the one. The second workflow is exactly the same. I'm going to use constrain insert. There's actually an edge at the top of the thread there that's quite useful. So select that, then select the hole. Obviously have to flip that, and OK. And you can rotate that around to get it set up a little bit better. Back to the home view. We would then add the other guide. There's one more part to add into the assembly, and that's the CO2 cartridge. Let's place one of those in the assembly. And this is going to take a couple of constraints to get it into that cartridge hole that we created earlier on. I like to turn it around just so it's kind of facing the right way. Constrain, centerline axis of both, click OK. I'm just going to drag that out because the second constraint I'm going to add here is tangential. So tangent, select that conical semicircular shape there, and then the flat end. Click OK. Return to the home view. That looks quite good. So many of the parts now have been added to the assembly, and that pretty well completes the assembly. I'll save that. Now let's review the completed car. So here's the car now with the split nose cone and all the fillets added. And this is the design I'm going to take forward. I'm going to check that out. And in the next activity, we're actually going to show you how you can check it with very simple sketches. In this lesson, you created a new assembly file. Place the straws, the axles, the wheels and the hubs, the tether guides and the cartridge in the assembly.